Welcome to my three-part series on my remote Node Red station setup. I've received a bunch of emails and questions about my remote setup, so I decided to make some videos. Hopefully this answers any questions you may have to get started. If you have additional questions, leave them in the comment section below. So part one explains the station setup and how all the radios, antenna, switches, miscellaneous devices are connected via Ethernet, serial, USB, and coax. Part two explains the Node Red dashboard and how we actually control everything remotely. Part three is I run through the programming flows and try and describe some of the logic on some of the flows. Now, if you're new to Node Red and you want to get started, I have a whole playlist on my channel to get you up and started and running Node Red on a Raspberry Pi, so go check that out. Also, there's a whole Groups IO mailing list dedicated to Node Red for ham radio. That's where we hang out and talk about ideas and share our flows with each other. Just search Groups IO and Node Red ham radio, and it should be the first thing in your search bar. So stick around, and we're going to get to the parts right now. All right, here we are in the programming interface of Node Red. So I've tried to group all of the things that I need in logical tabs. So we're going to go through some of the tabs here that we have, or I have programmed. So the first tab here is all of my device host monitoring. So I'm pinging things like the internet and my Flex and my PC that I have down there, all of my Pis, the KMtronics relay, the DLI Web Switch Pro. And I also, after I ping them, I put that, if it's true or if it's false and it's pingable, I put that as a global variable so I can keep track of if it's pingable or not. So those are just pinging those devices, setting the payload to false or true if it's pingable or not, and then indicating on a LED light on the dashboard that it is either up or it is down. So nothing really fancy here going on, but that's how I just at a quick glance see if anything is down that shouldn't be down. This second tab is the KMtronics relay. So here we start the flow with a timestamp, and it looks like I am pulling this device every 2 seconds. Oh, you can't see that, but I'm pulling the device. There you go. Every 2 seconds. So I'm also checking to see if that KMtronics device is pingable. So I have a global variable called KM relay status, and I go and grab that status, and if it is not pingable, then I close this gate so it's not throwing errors whenever it tries to connect to this board or the KMtronics relay. So in my previous example in part two, we talked about the flex power on that goes into the back of the flex, and if it's normally open, it's off. If it closes the relay to a normally closed position, it turns the flex on. So that is this button here that turns that flex on. And then the number 8 relay, it is the PTT that authenticates SmartLink. So you can see that it is pulling the board over and over, and it's getting the status, and then telling the button what position to be in, either on or off. Here is the 2-post DLI Web Switch Pro. Again, I've got this, is it pingable? If it is, open the gate. If it's not, close the gate. And then it goes through its polling cycle to figure out what is on and what is off. And here is the flex power supply. Here's my antenna disconnect, my Dell PC, my camera, fiber router, Netgear switch, the main Raspberry Pi, and then port 8 here is the backup Pi. Over here, I have got some lightning control, which we will get to in a minute. But basically what this says is if there is lightning at the station, I want you to disconnect or turn off port 2, which is the power supply to the Paradan antenna disconnect. So lightning strike hits within 50 miles. It sends a message to node red. It comes over here and says, hey, set global lightning parameter to true, set message payload to false, set message topic to outlet 2, and it sends that through the DLI, which then turns off the outlet 2 on the power supply, which is connected to the power supply, which is then connected to the Paradan antenna disconnect. So that's how that automatic disconnect happens. This tab here is just Raspberry Pi monitoring stuff. That is the gauges that you saw in part 2. So the temp, the CPU load, the memory used, disk space. Here's the reboot and shutdown buttons. Here's getting the local IP, and then also the uptime in seconds. Another DLI web switch. This one is in the back of the amp rack. And again, seeing if it is pingable or not, and if it is up, closes the gate if it's not, opens the gate if it is. And then, again, it's going through the paces here. The first relay is amp rack power. The second is station A. Third is station B. Then we've got the amp rack Pi, and then amp A and amp B. Here is where I'm setting the global variables here after it goes through its programming logic and setting the global variables for all of the different statuses of the switches. So I can have that in another flow if I want. So again, I'm controlling a port, the amp rack power. If lightning hits within a certain parameter, it goes ahead and shuts off the power supply, which then controls the Paradan antenna disconnects. Here is another flow for the second Raspberry Pi. So this is the amp rack Pi that I'm monitoring. Here on the weather tab, we have got we are pulling the weather at a nearby city. We don't have a weather station at the contest location yet, but hopefully we're getting one here soon. But we are pulling a location close, and that gets us just the general weather of the area. So one of the things that we do alert on is if rain is coming or in the area. I also have another location where I'm polling, which is Rolla, Missouri, which is down by the contest station. And I'm polling this through Open Weather Maps. And this is a free service. I think you get like 1,000 queries a day. So we're pulling this every couple of minutes to figure out what the weather is in order for us to be alerted if things are going south at the contest station. So I've got a whole bunch of different things: wind direction, weather details, outside temp, humidity, the sunrise and sunset, and then also some time since lightning. So we've got an LED that says, hey, if there's been lightning, and how long has it been since the last lightning strike? And if it has been less than 30 minutes, it is red, and if it is greater than 30 minutes, it is green, to show you basically if you're all clear. We've got some DX cluster stuff going on here. Really don't use that. That was in that DX cluster tab that you saw. And here is where I am doing most of my alerting. So different payloads come in from different tabs, and then they get parsed through a change node here. So in this scenario, we've got the lightning disconnect alarm. So the topic is lightning alarm at W0 ECC, and then the payload is lightning near W0 ECC. Antennas and amp rack power have been turned off. So that is my indication that everything has been turned off at the station, and it alerts me. So what I get this through email, and then also I have set up a Discord for our group, and we get those alerts through Discord through a node that you can install for interacting with Discord. So you have to set up a bot, and then you send the information through a bot. Down here, I've set up a Discord bot where it is looking at a certain payload coming from a certain channel, and if that channel is help all to post amp rack, a bunch of different keywords, it will go out and pull those global variables and pull that device and then send that back to Discord. So therefore, I don't have to log in to Node-RED. I can just get into my Discord server and shoot a couple of keywords to the bot, and it will give me a status back of what the station, what kind of configuration scenario that the station is in. Here is part of the camera flow that we're not using. Here is the Flex radio flow that pulls all of the different Flex radio parameters. And then here is the remote box. So this is the antenna switch that switches the towers, which then go to the MCM relays or the MCM switches, and then switch the antennas at the base of the tower. So we've got the different radios and the different antenna positions. Again, if the the amp rack loses power, then don't pull this device, but you can see it is sending an S here as the payload, and then it is pulling the device through TCP, which that pulls the Node-RED Raspberry Pi. I'm sorry, the Raspberry Pi that's running SEER to net, and then it's pulling that device, getting that status, and then telling what switches are on and off, and then sending that back through to, if a switch is turned on or off, then it has to send that information back through the system to tell the to tell the antenna switch what antenna to select. So that's that flow. Here's the flow for all of the rotators. So here is the presets. Here's the left and right and stop buttons. And then here's where it's pulling the device. And then down here is where it draws the maps and actually changes the values in the SVG graphic that you see with the azimuth map. So we've got Tower 1, Tower 2, and Tower 3 rotor. So all of those are the same. The only thing that basically changes is the TCP IP address that and the port number that you place in this node. Here is the first MCM antenna switch. So again, this is requesting the status. So antenna request, mode request, and then if the device is down, close the gate so it doesn't pull this and throw any errors. It's pulling the device. It's doing some error checking. And then here is some more checks to see if antenna 1 is it's true. And then send it to the button to actually select the antenna. So here is the XR5 beam, the 80-meter vertical, the 30-meter beam. Antenna 4 is no antenna. And then you've got manual mode and automatic mode in these MCM switches. Automatic mode is basically if you're switching these by band BCD data, and manual is actually if you're hitting the button or you're controlling it by Node-RED. So we've got it in manual mode. And we've got 3 of those. So all 3 of these are exactly the same. Switch number 4 is on its way. I haven't put it in yet, but that's where the flow will live. Up here at the top is the lightning detector. So this is, you can download this off of the Groups.io. You basically put in your lat and lon, and it will connect to this website here and grab all of the lightning that is happening around the world and throw it into your Pi. So if you have like a Pi 0 or a Pi 1 or 2, you probably don't want to install this because it's very intensive and it's got a lot of things going on. So what I have done is modified this flow to say, hey, if there is lightning within 25 kilometers of the station, I want you to send this out, this output here, and then we've got a manual override to say, hey, do we want this to be an automatic a thing that Node-RED does? If it is, then we open the gate. If not, we close the gate. So therefore, we're shutting down the station manually versus automatic. And this is where the information gets pushed to these different locations to shut down the KM-Tronics relay, to shut down the antenna disconnects. This is where this goes to. And then also it sends a message to the alarms page, which then I get that in an email on Discord. So that's where the the lightning detection is happening. Here is the toolbar, the blue or the turquoise toolbar that you saw at the top on getting all of the solar data. That's where that happens. And then what else do I have in here? Here's the internet monitor that pings the internet and then displays how long your WAN router has been down. Here is the band activity flow that looks like the heat map on DX Heat. And then here is some propagation and the DXpeditions and some solar data. And here's the geochron also. So that is basically all of the flows that we use at the contest station. If you have any questions about any of these flows, I can export them and send them to you. But most of these flows are just a collection of stuff that I have gotten off of the Groups.io, and I have put together and modified to be what I need at the station. So if you got any questions, hope you enjoyed this series, and comment below, like and subscribe. Thanks.